All right, here we are March 19. We're done with spring break. So we went through section 2. We were kind of wrapping up the 2D platformer. We moved into the first person shooter. And then we spent the rest of the time going over the gameplay, the kind of the major strokes of the first person shooter, and then looking at all those other scenes, Unity scenes besides the main scene that dealt a lot with UIs. Looking at the One World Space UI that was on the with the enemy hoverbots, and we spent a lot of time on like the render pipeline, talking about materials and shaders and geometry, VFX, how the VFX systems were working, and then we really looked at the player controller and got double jump going, and I was talking quite a bit about like the dot products because you have to know how like stuff is oriented toward each other quite a bit. And then we took a break. Now we're back up here for section 3. And so last week, or the week before the quiz, I should say, we went over the player input handler quite a bit. We went over the player character controller pretty extensively. There's a lot kind of going on in there. And we got double jump going. I'll just show that in the code real quick. And that had to interact with the character controller. So I think today, for this week, I think I'll cover. Let's see what's happening with the registering kind of the actors, the actor manager. Maybe let's take a look at Damageable. If we're gonna take a look at that, we're gonna take a look at health. And then once that's done, I'll probably jump into the weapon manager. But for double jump, this is the player character controller script. All I really needed was like a field. It's just a private bool sitting at the top to just know like, are we in our first jump or not? And if I right click on here and just say find all references, this will show me where I wrote this, where in which lines in this script I was using this. So this helps me kind of remember what I was doing with the code. So at some point we were setting it to true down here. So it looks like we were figuring out handle character movement, and down here, if we're grounded, should we allow a jump? So if we're grounded and the user presses the jump command, the spacebar, after we figure out everything we need to do a jump, I just say, yep, we're in his first jump is true. And it looks like I'm setting it false a few times, and then we actually do the double jump around here. So I always have to set it false. It looks like up here, if here it looks like we're landing. So in our update event, if is grounded, meaning if our capsule, if our character collider is touching the ground, and we weren't grounded, like the last frame we weren't grounded, so that means we were in a jump, we were not grounded. But this frame we did jump. Ground meaning we just touched the ground. In this frame, then there's a bunch of stuff happening to figure out fall damage, and that we should go into like a landed state. But that's where I say is first jump false. Like no matter what, this should just always set to false at this point because we've landed. And it looks like here in handle character movement, I remember this right. I had to put this if statement, pull it out of is grounded, and say if we're not grounded and we're in the middle of our first jump, and the user has requested a jump, then I just checked. I just made sure, like, hey, since the time of our last time jumped, so look, I probably recorded that somewhere. But as long as the current game time minus the time that we last jumped is at least 1/10 of a second, like give us a little bit of time off the ground, then I just copied a line of code that was when we actually did our first jump. It was basically take that character velocity and just add vector3.up, which is 010, multiply that by our jump force, and just give us another velocity upward to add. And then we're out of our first jump because technically in our second jump. So we can't do this again until we land and go into another jump. And last time jumped. So let's take a look at this one. Okay, looks like I last time jumped to set it to 0. And it looks like they were. I'm just reusing something. Looks like they were already using this for whatever their calculations were. So it looks like I just slipped in and was able to use it to do my own little time check as well. Cool. So let's take a look at actor, because usually this is kind of important in registering like who's in this game level, like players and enemies and NPCs. And so an actor usually is like some type of human character or creature. They might, have some intelligence in their behavior, or they might not. But they're just kind of like actors on the scene, just so you know like what's happening in your game level at a basic level. So let's see what's going on here. So affiliation, aim point. So we got some public. All right. Represents the affiliation team of the actor. So actors of the same affiliation are friendly. Okay. So they're just doing a number for that. So it's however you want to like manage your game. You could do them with strings or enums or ints, but for each number you're on a different team. So I guess 1 for player and maybe 0 or maybe 2 for the enemies. We can go take a look at an enemy. Okay, there's 0 and player is 1. And I guess if you have like NPCs or something, it could be 2. And we have to know that the aim points of all the actors, or the aim if they want to attack this actor. Okay. I thought it was there. Let's take a look. It's not where I'm shooting from, it's where people would target me. Alright, well there's no looks like players. The main camera is about 1.5 meters up. An aim point, so about 1 meter. And if you look at the capsule height, it's about 1.8 or about 2 meters. So the aim point is about in the center, like kind of like chest level. So it's where the location at a given moment, say if an enemy wants to shoot you and they look you up as an actor, they say that's the area I'm gonna shoot at with my laser or what have you. And then there's the actor's manager. So on start, when the script starts up, we have to go out and go look at all the game objects and find anything that has a component of actor's manager. So remember, these generics are super useful. So that means it must go out, and ultimately it'll hit this game manager here, and it'll see that there's this actor's manager. And so this is part of what we need to look at. Okay, it'll go out and it'll remember a reference to that, and then register. Okay, so if the actor's manager dot actors, so there's going to be a list of actors, so public list. So lists are interesting. I'll cover them in a second, but just know it's a collection, like an array, and it's of type actor. Actor being this script object. The script type here is an actor, and it's like saying how if this list called actors is a list of type actor objects. If it contains this script instance that's right now we're just sitting on player, but it's also contained on enemies and potentially others, this here. So if the list does not contain this, so contains is a method that the list object has, and you can basically point to a reference and say, hey, this is an actor object. You're a list of actors. Do you contain a reference to this actor object? And it'll return true or false. So it's saying false. If it's saying, hey, you haven't registered yet, this is false, we don't have a reference to you, then we use the add method. So contains and add will be methods of the list object. When we get over to actor manager, I'll talk more about the list. So he's basically just adding a reference of himself, of this object, to that list. And on destroy, I guess when this player gets destroyed, dies are either destroys when we move between. I guess when a player dies in a game level, you don't destroy it. But if you killed an enemy, more than likely they would just get destroyed. You'd be like, clean up this game object. We don't need them anymore. And when you destroy it, part of the on destroy is it'll call this. So and the other situation where destroy may happen is usually when you go between game scenes. When you load up another game scene, it'll destroy all the game objects that are on it, and only if like a game object has a little command like don't destroy this, will it stick around when we jump between like end level and when we leave the main level. This is interesting because on destroy is actually coming from mono behavior. So this is something else now besides awake, start, update, and what have you, is on destroy. So when you want to destroy a game object, you could just say destroy, and then you have to pass in a reference. They spelled wrong. And notice this is really shorthand for saying object.destroy. So object is like this super class, like coming from Unity Engine, the namespace Unity Engine, and everything is like an object. It represents like everything. It represents like components and assets and game objects, all inherit from it. So whether it's something is down here as an asset, something's up here as a game object, something is over here as a component object, all these are objects. And they're ultimately being inherited from this like super class called object. And when you can call a method from object, you can call it on any of those components or assets or game objects. And then saying, well, what do you want to destroy? And you have to pass in a reference to it or remove it. So when you say destroy on this, so when something else destroys, you say we shot an enemy, and we say, okay, we killed him, now we destroy that game object. On destroy says, okay, you want to destroy it, I'll clean it up. And if this game object has any component objects on it that have on destroy, we'll also call code there. So for example, before we wrap this up and we destroy everything about this game object, hey, why don't we go out to this actors list, and why don't we just remove a reference to it because it's gone and we don't want an invalid reference anymore. And that's it. See, it's a very light script. Who you're affiliated with, where can someone aim at you if they want to try to shoot you, what's the actor manager, how do you register and deregister yourself with the actor manager. So the actor manager looks even simpler. This is nice. We've been going through some pretty monstrous scripts recently, pretty hairy to unpick. And so it's nice to see some of these kind of higher level scripts that kind of just containing references or kind of organizing stuff. Anyway, this is the actors manager sitting on the game manager game object. And it looks like we just have a public, so a property, and it's going to be a list of actors. So it's not just a variable type actor, it's going to be a list of actors. And when you see this, this is like saying, so if you needed, whenever you set up properties, right, they're public, but it's kind of doing this behind the scenes. But if you need to get something more complicated, you can actually define it. So basically, when you're saying a public variable, in this case it's a list, but here it's like a public game object variable. Basically, it's like saying public get, public set. So get meaning you can read it, read its value. You can like go out and get a reference to it and read whatever it is. And set means you can write to it, so you have like read and write access. And sometimes you don't want to give out both read and write access. In this situation, and it's a little weird when I tell you that if you don't define a variable of public or private, by default in object-oriented programming it's private, because that's part of encapsulation, part of like one of its tenets. So we keep stuff private. But if you don't define, in this case, when you define how a property should behave, you actually, if you don't define the get or set, it's just going to be public. So this is like saying it's a public get. It's readable. It's readable, and it's saying private set. You can't write to it. So so this is a public variable, and that's what we call a property. And if you don't put this after it, just by default, it's public get, public set, because it's public over here. So you could read and write to it without an issue from any other any other object. And if you declared it as private, basically it's like saying private get, private set, like only this object can write to it. So you don't need to like add this. And if you just want it to be a normal property, public get, public set, then you don't need to write this either. But if you want to get a little like sophisticated, you can write your own accessors. You can write your own little methods for get and set. And you'll see like later on, sometimes you need a little bit of logic, a little bit additional logic when you want to allow someone to change your property or something. So you do kind of allow, you kind of want to write these kind of more intermediate coding styles. But basically it's saying, hey, this is a property, but you can't change it. You can only read from it. So, hey, go by all means, if you ever... any objects that are live at runtime in the game, if you ever need to know who the player is, don't worry. I've got this property referencing the player game object, and you can read it at any point, do what you need to do, but you cannot change it. Only I can change it. So notice underneath here, public void set player. So it's a public method called set player, and you have to pass in a game object reference that we're going to call player. And what's going to happen is we're going to set our player property to whatever this incoming player reference is. So notice their properties are uppercase. So actors and player, that's one thing to note. So it's kind of like a method where normally we start with an uppercase letter, where normally variables are lowercase. So over here we have an input, an incoming input parameter, and it's lowercase player. So when you define, you've seen a normal way of defining a method, which is, it's only saying it's an error because it's another name, not using it, but more like this. Just set player 2, where you have your brackets and you have the code here. But when it's really simple, usually when it's like one line, another option is you can use this arrow operator. So usually this is used with anonymous functions, which you might not see too much here. But this is like saying, instead of always having to write out your method like this, and it takes like all these lines, sometimes you don't even want to name the method. You just want to like create the method and run it at the same time. And these are these arrow functions that allow you to do that. That's a little bit more of an advanced topic, and I haven't really seen it too much. But the way that they're using it here is they're saying, hey, I don't want to break up this method over multiple lines. I just kind of want to say, hey, there's going to be a public method called this, and it's real quick. It's just like one line, and here's the one line. And when you use this, you don't have to use these brackets. So you could also do this on all in one line. It's just not conventional. You could say this as well. Like this is actually valid. It's just you don't. It's not really standard convention, so you don't see this. So you'll see like they're defining like a one-line function, and it'll just like look like that. So I just wanted to define what this like one-line function or method would look like and why it has this arrow expression. And I'm going to get rid of the second one because this was just to demonstrate what that's doing. But notice that this one-line method, all it's doing is setting our player property, which has a private set. So we can't even go in here directly. We can't say, hey, actor manager object, yeah, grab me your player property and set it to this. It would not allow you to get an error. But you can say, hey, actor manager dot set player, and then pass in the player game object, and it'll set this. So it is there is like kind of like a public set. It's just you have to call this set player method. So they do this for more like it's like the legal way to change a property. It's like the established authoritative way that usually there's more than one line. You do a bunch of safety checks. You say like, okay, well, there's certain bounds that this value can be set in, or it can only be set a certain number of times, or who's setting it, and you'll have multiple lines of logic in this method. So it looks like, I bet you when the player, somewhere in the player character controller or something, because it looks like the actor script on the player is just setting the player game object to the actor's list. It's not calling that set player, so somebody else is doing it. Actually, there's one reference here. I could just click that. This is really handy. It looks like it's in player character controller, so it is in this Uber script. Okay, on awake, go get the character manager. If it's not null, call set player to it. So it's being done over here. But in any case, so this is like a method that is a setter. So setters and getters are called accessors, and they're used a lot. So it's like you can't write to this property. You can't write to this property, but you can read this property. And when you can't write to it, well, how does it get set? Well, you just create a setter method and set it. You could also make this method up in here. You could also like define the function too. All right, so these are properties, getters, setters, accessors, and here's a set method, and this is a one-line method. And this is the arrow expression that's usually for anonymous functions, but allows you to define a one-line method. For a different class, your message is faded away. Hold on one second. For a different class, I tried adding a vector force to an object's transform, but I couldn't because it was using getters and setters. If you have the code, you could copy and paste it. I could take a look at it. Normally, when you add okay, so to the transform, normally you would do something like this. So you'd say like, so if you want to move a position, say, let me just do it in awake. So you'd say, okay, I have a vector 3 is like current position, and that's equal to like go get the game object. Yeah, nice. I love this autofill up. So it's like whatever this component is connected to, ultimately go get its transform and go get the position. That's a vector 3. And if you want to add something to it, like you're adding a vector force to it, you could say like current position plus, like, let's add another vector to it. and maybe this vector force, maybe you're gonna, I don't know, push it up in the y. We're gonna give it a big force up in the y or whatever. And then when you added those two vectors together, then normally what you do is you say, okay, I'm gonna go back, get that transform, and then I'm gonna set its position. So it might be something like this. So basically you grab the current position into another variable, and then you do some vector math, and then you set the position again. Is that basically what you're trying to do?
Yeah, that's kind of similar to what I was trying to do. I was trying to make an object that I could throw forward and up relative to the player's facing, but the object when you grab it was grabbed using getters and setters, and I couldn't figure it out.
I'd say I'd have to see the code. Maybe somebody implemented some different type of scripts or something. But normally, the transform. Let me just show the transform.
It might be because it was an XR kit, and it's virtual reality kit.
Might be. Yeah, I have to take a look at. Everything's going to be written a little different. But the way the transform works is, I think there's a way to, if you're not using, I mean, it sounds like you're using forces. You should really be doing it through the rigid body, because then you can like add velocity. That's what most of these games are using, is because you could just say add velocity or add force or something. But with the straight up transform, you can just give me 1 second as I read through this. There's a position. Rotation. Usually, they may have gotten rid of it. Usually they'd like look at and move towards. They had some like helper methods to help you. Here's like look at, rotate around. Translate moves the transform in the direction and distance of the translate. I've seen this used quite a bit. So you don't need to do like vector math. You can just say, hey, take this transform, and then there's this translate method, and you can throw in a vector 3, like, hey, I want it to translate. I want it to move, say, 3 units up and like 10 units in the local Z, or, like I want it to move forward and up a little bit. You pass that in, it'll just do like the math for you. So anyway, you can look into these. So it's the translate. The look at is really useful to have something rotate toward and look at something if you want to update the rotate, want to figure out like the quaternions and stuff. This is really helpful. So anyway, let me get rid of this code. So ultimately, when this thing wakes up, all it does is it creates a list of actors that are empty. And it gets filled out by players and enemies as they register themselves as an actor. So then we have a list of actors in the scene. So and notice it's capital A. They're capitalizing their properties. But I just wanted to show you the kind of the methods that are available here. So add, you can add an element or an item. You can clear out the list, just empty it out. You could loop through it for each through it, and then do some type of like, multiple lines of logic for each element in it. You can check if it contains an element, add a range. So you can give it like a range, like another array or another list, and like add it, append a smaller list art to this bigger list or whatever. clear, contains copy if it exists. So notice how it's a pretty robust and advanced, and it's like you can remove elements at like certain positions. You can remove whole ranges. You can reverse it, sort it. It's complicated, which also comes at, no, I won't say a price, but I will say that when you use, normally you try to use arrays as much as possible just because they're simpler. There's less complicated computation around it, but you can do a lot more things quicker with lists because of that complicated abilities that are added to it. So it's like a list is like an upgraded array. A list can grow. Normally, when you create an array, it's a fixed size. Like you kind of know ahead of time how big your array is, and you could just like put stuff in it. You just say, okay, create an array of size 20, and then you can like access stuff and change it, but you can't change the size of it. And an array will grow dynamically. So these are two of the simpler data structures, arrays and lists. And normally these days everyone just uses lists just because usually memory is a lot cheaper. But I just wanted to show, I just want somebody to talk about the heaps and stacks for a second. Because while this is kind of more of a computer science topic, this is something that you should be aware of. Like, I don't want to get... So... Oh well. So notice that a lists are using the generic, the angled brackets, and notice up here this is the first time that using system collections.generic is highlighted, and this is a generic data structure. Like you have to state which type it's going to be used on, but you can make a list of any type of object, but you need to state what type of object, what type it's going to be for. Even for like ints, or floats, or actors, or game objects, or transforms, whatever. Same with arrays. So there's a strongly typed language in C#, and you have to state like what your data collections are going to work upon. But let me just finish my previous like heap versus stack. This is just, I'm not going to get too deep in this, but some of the benefits when you think about game programming, some of the benefits you think about is like, here's a good, okay, here's good. Okay, the kaboom, I like this. So you have your RAM, your dynamic memory, right? And usually you got a lot of free memory, but as you have a lot of applications running, it's going to start to get filled up, right? And I don't know if you ever hit situations with either your GPU is maxed out or your RAM is maxed out and your computer just kind of craps out. So when you run a program, it'll take stuff that knows like its fixed size. So for example, right, so you have a whole bunch of arrays. Okay, this one is size 5, size 20, size 100, size, it doesn't even matter. It's like I have arrays declared at the beginning. Then it says, okay, I know how much memory you need, and it can start with what's called a stack, because a stack is like a unified area of the memory that we know exactly what our sizes are, so we can allocate the size of your stack to your application because we know what you're exactly going to need. You've defined this many variables, you've defined this many like arrays of this size. Here's your stack, kind of. So like the operating system has a set size to how much RAM it has, and that RAM is broken up, and the operating system manages how much of a stack and how much of the heap is available. And normally the stack is cheaper to use. Usually there's more of it in it, if you can define your stuff beforehand, like your fixed array size or what have you. But a lot of these days, everything goes onto what's called the heap, and it's called a heap just because it's messy. It grows. It's dynamic. Stuff will get deleted or added over the course of your app runtime. So that's what these kind of holes are. It's growing, but you're deleting stuff, but you can't really compress it. Because so say if you're adding more, like say your list, yeah, you're using a bunch of lists and they're dynamically growing or maybe even shrinking as like you're using your list over the course of your runtime, or you're removing game objects and stuff. You might not be able to fit new objects within these holes that are being coming available in the heap. So the whole, like if say this was like the size of an integer and this was like the size of a game object, but you've requested say dynamically at runtime another list or something, and it's too big to fit in all these, and we have to add another section to the heap. And so this could be dangerous. It's more you just don't want to have a crappy runtime for your player, so you want to try to keep your heap as small as possible. But these days, most everything, like an object-oriented program, everything is like on the heap, and memory is usually cheap, so nobody really cares about it. But lists will go on the heap because they're dynamic, and normally arrays, they're declared at the beginning that they'll go in a stack. But if stuff is being created like in the middle of your runtime, middle of the game, and it didn't exist at the beginning, even if it was something that's more of a static element, it would still kind of have to go into the heap. But there's just a little heads up of like when you're using memory for your game, that we do have these ideas of stacks and heaps, and that the dynamic collections go in the heap and the more static ones go in the stack. So saying that these days, it's not really a big a deal, and like you just have to get used, like use data collections, just get used to them, and like later on when you get really understanding of the situation of like how these data collections are working, then you could be like, you can optimize. You'd be like, oh, this situation calls for an array, not a list. But before when you first start using, you might not really understand the differences or what's the point of the different using one or the other, and so you just use the easier one, use the list, because there's so many methods available for you. You don't have to like manually count up the elements or like move through them in a for loop to try and find something. Like there's a method called contains or located at or something that'll find elements for you. So anyway, that is a list. Maybe since we'll just wrap this up, maybe see if there's an image for doubly linked list. Okay, so just a little bit more computer science, I guess. So lists you could think of as linked lists, and you'll see these in computer science, and so you have these elements. So kind of how I showed you, like an array has like you can like reference each element with a number, and usually with like linked lists are a little different, where you come in and you have a reference to the beginning called the head, and then you have an understanding of the object at the beginning. This object, say, contains 5, say it's an integer object, but it also has a pointer or a reference to the next element and the next element. And so this is why I call it a linked list. There's like a link to each element, and you can only move through the list in one direction. And there's some benefits to arrays where you can kind of like jump in and access an element anywhere, or there's something like a linked list where you have to move through each element to find the one. You move in one direction, and then there's a more complicated one called a doubly linked list that can have pointers both for next and for previous. And if you're at the end of the list, the pointer points at null. All right, so that was actors and actor manager. And let's take a look at Damageable. So it looks like Damageable is going to rely on quite a bit on the health script. So we have like a damage multiplier, sensitivity to self damage. So I guess if you shot one of your grenades down into the ground, and it was close enough to you to take damage, and say there's an enemy right there too, the enemy would get like a 1 multiplier, and you would get a 50% multiplier on the grenade you threw too close to yourself. And then it wants access to the health script. So here we have that, what I just described before, those accessors. So it looks like we can get this, but we can't set it. It's a private set. So nobody can change this. So how do we set it? Well, it looks like on awake, it says go out to the game object that we're on and go find a component of type health. And if we do find it, then I see. So go, this says like go on the game object that we're currently on and go hunt for a component of type health. And if we still don't find it, then go up into the parent, get component in child, in parent. So go up to the parent game object and hunt up there for the health component. In this case, I'm pretty sure we have Damageable is sitting here, and we have health right here. I would have them sit right next to each other since they're so related. So we have an inflict damage, and it looks like when somebody hits you, so if you shoot and your projectile gets into range of an enemy, I think it calls this inflict damage. It doesn't interact directly with the health script, but it looks like let's see who's calling this. So damage area, yeah, it's just the projectiles. So this projectile standard is like the laser blast, and damage area is like one of these explosions, like a grenade or something. But on their scripts, they have inflict damage. So if they're within range of something, you call inflict damage on that damageable object. I think this goes beyond actors too. Like you can have props like exploding barrels and walls that get destroyed. And you could use damageable and health on them as well. So anyway, a damage is explosion damage, and the damage source comes in. So if there's a health script, then it looks like all that computation is done. So it looks like first we take the damage in, and then we see if it's explosion damage, there's some multiplier. I guess that's up here, so it's just a 1. So if you want explosion that give added damage, you just up that. Okay, and if whatever the health script, whatever game object it's connected to, if it's also the same as this damage source coming in, then that's how they figure out if it's self damage. And then ultimately it goes to the health script. It says, hey, call take damage. And so from there, we can go to the health script. And let's see. So we have public float max health. So you have max health. It defaults to 10, but they're setting it to 100 here. Then we have critical health ratio 0.3. They left that alone. So health ratio at which the critical health vignette. Okay, so that like darkening of the screen starts to happen. So it looks like we have some Unity action, so some events. And so these are public, so anyone can subscribe to them on damaged, on healed, on die. Looks like we have some other properties: current health, invisible, can pick up. So notice these are capital letters. So here we have a get set. So they're not set. That's weird that they're not setting private set. All right. So you have current health, invincible, and can pick up. So it looks like these two can be written in red, so you can change them. So can pick up is a method, and it's a one line method. And so that's why we're using this arrow expression here. So it's just saying, is current health less than max health? True or false? This thing just returns a bool. So if you have max health, basically, and if you hit a health pickup, and it does a check here, like, can we even pick up this health pickup? Should we even bother with it? Like, are you at max health or not? Get ratio, just how much is your current health to max? Are you in critical state? So get the ratio. So it's calling this method. It's kind of it's hard to see that because there's this, and this is the arrow expression, and this is like saying less than or equal to. So this is still a one line method call, but what it does is it calls this. So this is some number between 0 and 1, and it's like saying, is this less than or equal to the critical health value, which we set to 0.3. So if this is less than 0.3, then we know that we're in a critical state. And then here's a field: are we dead? And so start, whatever our max health is, set our current health to this. And there's a public method heal. So heal amount comes in, and we figure out how much we should add. Yeah, okay, because we can't go over the max health. And then on heal action, so take our current health, take the health before. How much did we actually heal? Because we could clamp it. We could like have more than enough. And if whatever we healed actually happened, like it's not like we tried to heal ourselves and we were already at max health and nothing happened, like we did actually heal something, then this is how we're invoking that unity action up here. So it's like saying unity action. When you see this question mark, this is like saying, does this exist or is this null? So it's only null if no one is listening to it. So what we have here is we have 3 events, right? One event, when you see these generic angled brackets, this is like saying, okay, on damaged is an event, and when it gets fired off, it can only call other methods that are going to receive a float or in a game object. And on healed, when this event gets triggered and its subscribers, its listeners get their methods called, their methods need to only receive a float because we're only going to send a float. And on die is like calling a method with no input. Like there's we're going to call methods that don't receive anything. So this is like saying, okay, we did actually heal some amount, so we're going to invoke the on-healed unity action, the on-healed event. But this is like saying, okay, is this null? And if it's null, then we don't do anything. So it's like shorthand of saying, is on-healed, like an if statement, is on-healed null, and then saying, okay, it's null, then it's not null, then we can invoke it, we can call it. There are methods that are listening to it. But everything is like shorthand these days. So this is like saying, Okay, if this is not null, then we can move forward and we can call this method on it because we know that it exists. And in the idea of an event, it only exists if it's being referenced. If there's other event subscribers, event listeners that are listening to the onHealed method, onHealed event. If nobody's listening to it, what's the point of calling it? If there's an empty listener list to it, basically. But if people are listening, we're going to pass out the onHeal truth amount. And notice it's a float. And that's why whoever is going to subscribe to this better be expecting a float coming back. Take damage. So looks like it's kind of similar. Damage comes in, damage source. If you're invincible, just do nothing. Take your health. Take damage off your current health and then clamp it. So if it went below 0, it'll basically just clamp to 0. And then we say, hey, did anything happen? Well, we have our health before and we have after damage is taken. If something happened, then we know that you were hurt. So there might be situations where maybe you have armor or maybe the explosion was just far enough away where you were received like a damage call, but the explosion ultimately gave you 0 damage. But whatever the case, in this situation we did take damage. So we're going to call the onDamaged event a unity action. And this one expects to send out a float in the game object. And then we say, hey, is anyone actually listening to this event? If so, then let's invoke the event. Let's call all the methods listening to it. And this are the two variables we're going to pass out. This is a float, and this is a game object. And if we come up here, it's expecting to send out a float in a game object. And after all that's done, looks like handle death happens. So handle death is just saying, hey, if you're already dead, forget about it. If your current health has dropped to 0 or below, then we're going to say you are dead. And hey, is anyone listening to onDie event? Then let's invoke it. Let's get their methods called. And then we have kill. Looks like if you just, I think this is probably when the player, it plays when the player gets too below. They're doing that Y check on it. And if it gets too low, current health is 0. We're going to invoke onDamaged for whatever reason. And then we're going to handle death. And you have current health of 0. So then onDie will be invoked. Cool. So before I move on, I covered actor manager, damageable, and health. So let me just stop for a second, see if there's any questions. All right, I think I'm not going to bother with the jetpack right now since it's not like implemented in any meaningful way. Maybe I'll look at it as like we get toward the end and we're looking for like some other fun stuff to look at. Actually, while we're on, I'm not going to get into the weapon manager because it's way too big. But since we're talking about all this stuff, let's look at what an enemy has on it. So we have the enemy controller, really big. Not going to cover it right now. Enemy mobile. Is a mobile enemy? Nope. But it does have health. It does have the health bar, which we looked at previously. Nav mesh. It's like a whole other topic. You have actor and compass element. So their actor, notice their affiliation is 0. They're the enemy team, but there's nothing else that's different on actor or actor manager. Health is going to be all the same as well. And they should, I didn't notice, but they don't have damageable. That is weird, and I bet underneath somewhere there must be damageable. Here we go. I got lucky. I just saw a hitbox. I was like, that must be it. Okay. So there's a sphere collider. If I make it this collider here is the take damage volume, and notice that the damageable script sits here, and that's why, if you remember in damageable, it's like saying, hey, when I awake, go get health, which is going to be on the same. It's going to be a component of the same game object. Hey, it's not there. Go up to the parent and find the health component. So that's why, because here sometimes damage will sink down here and then go up here and find my health. All right. So for whatever reason, they wanted to put it on a child object and put its collider by itself. Sure, it made sense. The world space health bar we've looked at. This is connecting up. It's basically always looking at the health on update every. This is a little subpar, I should say. Since the health script does have events for take damage and everything, it shouldn't be every frame checking health, because that's what events are for. You just don't want to check stuff every frame. So this should basically be listening to on damage, and then that's when you update the fill amount to, okay, where are we now? You took damage. What's your current health? And divide it by your max health. And everything else had to do with looking at the camera and setting colors on it. All right, these are too big. Let me take a quick look at compass element, because we looked at the UIs a bit, and let me just quickly look at the turret. I just want to make sure he's got a controller, and doesn't have mobile, but he has health in the health bar, and an enemy turret script, actor, and compass element as well. All right, so I think just with the time left, maybe we'll get the compass element, and that'll be it for class. Okay, the marker on the compass. So compass marker prefab. Interesting. Okay. So this must be those little like dots. So if I click play, sometimes it's frustrating. Why does it need to like do all this stuff when I haven't actually done anything? Okay, let's pause it. So let's see, compass. So underneath compass, we have got all these clones. These, well, there's only, okay, this must be beyond the enemies. So we have our two enemies. These directions must be either to like objectives or something else. But let me just turn this on and off. Yeah, I was expecting these to turn on and off. Maybe because it's paused. Let me click play. Okay. Yeah, it is. I just saw it. It's turning on and off here. So compass marker, it's got a little script on it. Somehow it's creating a little dot. I guess here's the image. Yeah, it's like a little circle. Okay. And that's it. So we can look at this script, but basically that's the little prefab. This is the whole prefab that gets instantiated per enemy. So that's what this thing is. It's a little weird. It's sometimes they'll do this where it's like compass element, and if you come down here, it's actually the whole prefab, but it's actually referencing the script in the prefab. It's referencing this component right here. So anyway, notice it's compass marker. It's not like prefab or game object. It wants to know about the compass. which I'm guessing is like the UI compass up here. And on awake, go out and find the compass. All right, so that's okay. That's this compass script right here. And instantiate this prefab up here. And then call the initialize method of that script that's on that prefab. And then go to the compass and register the compass element. And on destroy, unregister it. Okay. So compass marker prefab. Is this one here. This is the script that sits on the prefab. So we got the image, some UI settings, some colors, what have you. So initialize. So we're going to pass in the compass element, the text direction. So if direction and text contact, let me just take a quick look. So text direction's empty. Text override if it's a direction. Okay. So this is going to come in as null. So based on settings up here, use this marker as a magnetic direction in text direction. Okay. So whatever the text element is, else compass element transform get component the enemy controller. So whatever the enemy controller is on this compass element that we passed in, we'll grab that and we're going to listen to it. Okay. So it's like saying we haven't gone on detected target and lost target yet. So we haven't looked at the enemy controller, but it does have some events on it that say like when the enemy controller has detected a target or when they've lost a target. So they're basically saying there's two ways you can like put this compass element up. One, it like appears when the enemy starts tracking someone, and remove it when they've lost someone. And that's how these different color changes happen. Or else you have like a more static way of putting the compass element up on the compass. And then the last script dealing with that is up in the compass here. We have this compass script. So you could think of this as like the manager, like here's the UI compass. So it's got a bunch of like settings for how to position it and place it in the UI. And where is it? The rect transform. Remember, these are only the UI game objects have rect transform. And so dictionaries are interesting. They're actually used a lot, and it's getting into a more, it's definitely an intermediate data collection, data structure. They're more complicated than a list, an array or a list. And the benefit of them is that they have what are called key value pairs. So this is the key, like whatever comes first is the key, whatever comes after is the value. And the benefits of a dictionary is it has constant time lookup. So for an array, arrays usually don't grow dynamically, and like you don't always know the element, the position of the element that you want. Lists, you have to move through them from left to right, and you have to like it takes constant linear time because you have to move through like each element to finally like find whatever element list you're looking for. Dictionaries are very interesting and they're used a ton everywhere. And the benefit of them is that you can associate a key to a value. It's like a mapping. It's like an enumeration, but you can state whatever the key and the value is. It's a list of key and values. And if you know the key, you have constant time. You can look it right up. So normally the key is something like a reference to a game object or a transform, or it could just be like a number or something. But in its simplest form, um, it looks like this. So here are the keys, like each are distinct and each key is mapped to a value. In this case, it's a string to a number, so very similar to an enumeration. But normally they're referencing their object references and they get pretty elaborate. Um, but here, like the key is of asteroid and the value is like a long description of it. I'm trying to find ones that are pointing to objects. So, for example, this three, this key. So this dictionary here has 3 entries, right? These two are pointing just to like a string value. Very simple. This one is pointing to a whole other dictionary, which has other values in it. So just saying that they can get rather complicated. And yeah, okay, this is talking about the internal strike. Now that's like a programming level type stuff. But just know that dictionaries allow you to get like constant time lookup, because if you know the keys, which normally they're just references to other objects like game objects or transforms, it's like instant to look up whatever you need, whatever you've mapped the values to. So these later on in your game programming career, they're going to come up a lot. But it looks like in this situation, we're just mapping transforms of whatever these compass elements are to whatever their marker is. So I guess it's really quick. Like if you know that the transform, you can look it up and you can get the compass marker from it, like instant, like real time. Constant time just means like almost instant. And it must be usually use that when you have to like look stuff up a lot. So it looks like we're going out, getting the player character controller, getting its transform, and setting the width and height of its little like gizmo, which is at the top of the screen. So this thing up here. And on update, this is all very WIP, work in progress. So for each element in the dictionary, we get a distance ratio, distance, height, angle, and if the element is a directional element, we look up the vector3 signed, angled. Okay. So else we look at the target direction, project on plane. This I'm going to have to spend some more time with. It's going to take a while to go through what's happening here. But you can register a compass element. So basically, see, we're adding to the dictionary whatever that element is, and then whatever its marker is. And we're unregistering to the element. So basically, what this is doing right here is somehow figuring out, okay, the player is somewhere in this game world, and something is going to be a compass element, like maybe this enemy. How do we figure out the direction, the orientation of like the player, like where the player's oriented, rotated towards, and where that that enemy, that compass element is, and how do we visualize that on this like compass line at the top? So right now the enemy's like directly in front of me, and their little dot is right, in the middle of the compass. Even if I look down or look up, I'm still kind of oriented toward them. And as I look to the left, you see like they're getting almost off the compass range, and now they're completely off. And same with this direction. And it really doesn't matter with up, down. It's really this like left and right looking. And as I move, my orientation to them changes as well. So now it's like wherever the player is, position and rotation wise, in respect to the position of the enemy or the compass element, how do we figure out where the dot is? And then it looks like the dot, maybe it gets bigger. It looks like this one is down a level, so they're down a bit, and this dot is bigger because they're closer. But let me see, as I move past them, he gets really big. See, as I move down, see this dot is moving from down to up, and the dot's getting really big. Yeah, so we have to deal with how big the scale of the dot. Is the dot like vertically aligned? And if we're like on another level, notice how they go down, and the farther we get, the smaller they get. So that's quite a bit of things going on here. We have to cover that next class. All right, let me know if you have any questions. Otherwise, I'm going to stop the video.